meshing and CAD import for Autodesk Simulation Mechanical 2014. Whenever you're dealing with assemblies that have both solid and surface geometries and trying to import them to Simulation Mechanical, you often end up changing the mesh type for surface geometries. In the 2014 release, we've added the capability to recognize those surface objects and change the mesh type automatically to plate and shell so that our users, upon import, can simply click the Generate 3D Mesh button and get a successful mesh. This improvement has a secondary benefit such that when they're trying to do parametric design studies, those surface objects, such as the ones that we've shown here in transparency, will come into Simulation Mechanical every time after a geometry update, and the parametric design studies will run successfully and give them the new geometry and the new results based on the parameters that the user sets. We've done a couple other improvements to meshing, and the second one is around part imprinting. So if you're dealing with a surface-only geometry and importing your full assembly as a single part, we've implemented a new feature called imprinting within parts. And this is especially beneficial when you have two adjacent surfaces coming together and you want good mesh matching to get accurate results. And the third one around meshing is has more to do with databases around meshing. In the 2014 release, we've implemented a capability to delete mesh, which will allow you to select a certain part or a group of parts and delete the mesh associated with that and clean your database to start a simulation from scratch. This was a common enhancement request from our user base and will be beneficial to those advanced users who want more control over their mesh structure. Now let's take a look at some of the associativity improvements we've done on this release around meshing. Oftentimes when we set up an analysis and run it, we want to refine our mesh several times to make sure that our results are accurate as the mesh gets finer and finer. So in the 2014 release, we have implemented an associativity for some of the nodal loads and boundary conditions. This was another common request from our user base. So whenever you're dealing with nodal loads and boundary conditions assigned to set coordinates, such as the ones in the center points of joints, bolts, and remote loads and constraints, those will be kept in our database as associative items. And whenever you remesh your geometry, so in this case I go from a coarse mesh to a fine mesh, we will automatically assign those loads and boundary conditions to the center points of bolts, joints, as well as some remote coordinate that you've picked in space. And this will allow you to try what-if studies and mesh convergence studies with higher accuracy. Now let's take a quick look at how this works in the software. Okay, here I have an inventor assembly, and it is made up of multiple solid objects and surface objects. Those surface objects come into Simulation Mechanical 2014, and the mesh type is automatically set as a part mesh object, and it is set to plate shell, as you can see, which allows me to just simply click the Generate 3D Mesh button, and it will automatically assign brick elements to the solid objects and plate elements to the surface object. When I define its thickness, I'm essentially ready to set up the rest of my analysis. So I add some loads and boundary conditions to finish the setup, and then I can run my analysis. But I also want to highlight this new functionality of nodal associativity, so I'll add a joint. I select the surfaces at that hole and create a joint. And you will notice that you can set your part, surface, and layer information for joints in this release as well. So I select the material and select the central node to assign a nodal constraint. Now, let's say if I want to define a finer mesh, I change my mesh size to a finer percentage and remesh the geometry. And you will notice that the software will automatically not only keep your surface loads and boundary conditions, but it will also keep your nodal boundary condition that's at that center point. It also keeps your element type, element definition, and material information for solid objects and surface objects. To summarize, in these two slides we've talked about some of the new meshing improvements we've done to the 2014 release, and we covered some of our nodal associativity.